Okay, here's warm-up number 18. Let's solve this by completing the square. So I'm going to solve for x. We've got, if you tried to factor this, it actually wouldn't be factorable, so it'd be a dead end. So our two other options are quadratic formula or completing the square, and you really need to know how to use both of them. Okay, so completing the square. What I'm going to do for completing the square, first off, I'm going to look for a mystery number, okay? And the mystery number is not negative 16, but it's going to go in this slot. So I'm going to put plus, and then I've got an empty box, okay? I want to move this 16 over to the other side of the equation. So I'd add 16 to both sides, okay? And then since I'm going to be adding some number here on the left side of the equation, I want to add the same number to the right side of the equation, okay? And then the mystery number that's going to go in both of these slots has a little formula, okay? And the mystery number, by the way, is going to create a perfect square trinomial on the left side of the equation, where I'm going to have something times itself on the left side, okay? And the formula for that, it's going to be b divided by 2 and then square the result, okay? So in this trinomial, the b is 4, so I'm going to have 4 divided by 2 and then squared. So 4 divided by 2 is 2. 2 squared is 4. Okay? So that's telling me that I should put a 4 in both of these slots. Okay? So on the left side of the equation, I'm going to factor this trinomial now. And it should factor into something times itself if we chose the mystery number correctly. Okay, so I've got 4 up top and 4 on bottom. So I'm thinking of ways to multiply to get 4. Well, how about 2 times 2? Because 2 times 2 is 4, and 2 plus 2 is also 4. So this is going to factor into x plus 2 times x plus 2, which you could write out like that, but I'm going to write it out as x plus 2 squared. Okay, the quantity x plus 2 squared, because that's going to be important in a second. Okay, on the right side, I just do the arithmetic. 16 plus 4 is 20. So I've got it down to this. So now that I've rewritten this equation like so, what I can do is I can take the square root of both sides of the equation. Because if I do that, I'll only have one x term, and that will allow me to solve for x, okay? So I'm going to take the square root of both sides of the equation. The square root of x plus 2 squared is just going to be x plus 2, okay? And I'm going to take the square root of 20 as well. But what you want to remember, there's a positive root and a negative root of 20. Okay? So, let's say I had 25. Well, 5 times 5 would be 25, but also negative 5 times negative 5 would be 25. So anytime you take the square root of both sides of an equation, you're going to you want the positive and the negative root. It's different when you're just undoing a square, but when you're taking the square root of that right side, you have that plus minus, and that's super important. Okay? Now, I'm trying to solve this for x. I've almost got x isolated. All I have to do is subtract 2 from both sides. So I could write plus or minus 20 minus 2, but usually we're going to put the negative 2 in front of the plus minus, like that. Okay, so I slip that negative 2 in front of the radical, and also in front of those signs, right? Sometimes I see people stick it right there, but that's not correct, okay? So this is what x equals. I could put root 20 in my calculator and get a decimal approximation, but let's do simple radical form, because that's how we're usually going to do this, okay? So I'm going to break the 20 apart, looking for twins. So 4 times 5 is 20, or 2 times 2 times 5, and now I found some twins, okay? So one of those is going to get out, and one won't. One will disappear, and the 5 is going to be trapped in there, okay? And the 2 is going to go right in front of the radical. I see people put that 2 other places, like out here or something, but yeah, just think about just what would you do if you just had this. It would equal 2 root 5, right? And then this is my final answer. And you could get a decimal approximation. Let's say you were graphing these or something. You probably want a decimal. Well, you can put 2 root 5 in a calculator, and you can do negative 2 plus that and negative 2 minus that, right? Okay, so let's try it again on this next problem. So I'm going to move the 16 over just like I did before. to make space for my mystery number. So it's going to be a positive 16 and then plus something. Okay? All right, and then for this, which will also be this, I'm going to use, here, let me separate this a little bit. I'm going to do b over 2 squared. Here my b is negative 3. Oh boy, I've got a fraction. But that happens sometimes, right? Fractions happen, okay? So negative 3 over, well, negative 3 times negative 3, if you're thinking of this as negative 3 halves times negative 3 halves, I'm going to get 9 over 4. Or if you just square the top and square the bottom, that gives me 9/4. So 9/4, I don't usually like to use this style of fractions, but just because I'm short on space here, I'll do that. But 9/4 is going to go in both of those slots, okay? Now, left side of the equation, this is going to be a little bit weird, but I'm going to want to factor this. It should be a perfect square trinomial. Now, it's a little weird because I'm thinking, oh, okay, you know, if I'm doing a diamond problem, 9/4 would be on bottom. I think what times itself equals 9/4 since this is going to be a perfect square. Or if you're just thinking about, you know, FOIL, this is something times itself would have to equal 9/4. Well, the key to that is right, and how we found the 9/4 to begin with, negative 3 halves times itself. Now, positive 3 halves times itself is also 9/4, but I know I want the negative one because I got the negative right there, and also my middle term there is negative. So this is going to be negative 3 halves, okay? And then on the right side, in order to combine these, I'm going to need a common denominator, okay? So I'm going to take the 16 and multiply it by 4/4. So that's going to give me 64/4. I mean, I guess you could make decimals and just add the decimals together, but let's do this so we can get an exact answer without even using a calculator, really. Okay? And then when I combine those, 64 plus 9 is going to be 73. Okay? So now I'm ready to take the square root of both sides of the equation. Okay? Got it down to that. And now let's isolate the x. So I'm going to add 3 halves to both sides. Okay, and I've got this. And to be honest, I'm totally fine with this answer. Sometimes I think your book will continue to mess with this equation because we could write that as root 73 over root 4. And root 4 is 2. And if you did that, here, I'm just kind of skipping one little step, but that's root 4 on bottom is 2. Now I have a common denominator, right? So then I could say, okay, well then x is going to equal 3 plus or minus root 73 all over 2. So you can combine that into one fraction. For me, that doesn't feel simpler than this one, but so I'm fine with either one of those. It's kind of like a lateral move. Okay. All right, then we've got a quadratic function here, or quadratic equation. It's going to be a parabola. We're going to graph this. So first thing I'm thinking is, oh, this is going to open downwards because it's negative at the beginning. Okay, so that's worth knowing. All right, so to find the y-intercept, I'm plugging in 0 for both x terms. Both of those are going to drop out then, and then this is going to be the y-intercept. Y equals 1. So you can go ahead and write out, you know, plug in the zeros if you want, but that's what's going to happen. It's always going to be the c value when you're in standard form. Okay? Axis of symmetry, I'm going to do x equals negative b over 2a. That's the axis of symmetry formula. B here is 4, and a is going to be negative 1, right? And then let's simplify. Okay, so axis of symmetry is not just the number 2, it's the line x equals 2 because it's a vertical line. So let's go ahead and put that in our graph, x equals 2. There's the axis of symmetry. And then the vertex, I know the vertex is going to be on this line, so it has to have an x coordinate of 2. So it's going to be 2 something. And I just need to figure out what that something is going to be. Okay? All right, so the way I'm going to do that is plug 2 in for x into the equation. Okay, and then I'll start simplifying this. So remember to do the exponent first, because it's really like -1 times this other stuff. And so you want to do exponent before multiplication. Okay, and -4 plus 8 would be 4, plus another 1 is 5. So my y-coordinate is 5. Okay, so vertex is 2, 5. Let's put that in the graph, 2, 5. And then it's really easy to reflect this point over. I see it's 2 units from the axis, so if I go 2 units out that way, and then I can see I'm definitely have a parabola that's going to open downwards. It's going to have the same basic shape as the parent graph, right? Because, I mean, it decides it opening down. But there we go. All right, that's it for today. See you next time.